Good day, welcome to DASYLab. Today we want to analyze the outputs of various power supplies we have around the shop. And specifically I'm looking for the ripple in the output voltage. So we're going to find a min-max on that, calculate the delta, and we'll also look at the RMS. Software we are using is DASYLab. I'm currently running version 13. And the data acquisition will be a USB 1616HS. So let's go ahead and get started. We'll say new folder or new file. I like to start off by dropping some controls in to start and stop the program. Let's go ahead and double click that. Start, stop. Okay. Go ahead and bring that up. This gives us some nice big controls other than trying to fumble around with the little ones up there. So the first thing we need to do is get an input. So we're going to go to the measurement computing directory, grab an analog input, and double click that, go to measurement, modify, and we're going to crank that up to 500,000 hertz, 500,000 samples per second. Okay, okay, okay. Next thing we'll do is drop a YT chart on there, so that we can graphically see the wave coming out of the power supply. We're going to copy the inputs on that. Next we'll go to statistical values to get the min-max. And drop that on there, double click it. Channel 0, we're going to make that our max. Maximum. And we want to do cumulative. Add another channel. Make this our minimum. Set it to minimum, and again cumulative. Okay. Go ahead and connect port 0 to 0. Clean it up a little bit. Connect your next wire. Okay, to display those values, we'll bring out a digital meter. Display. Digital meter, drag it out, double click. Channel 0 is going to become our max. We're going to display that channel name on our meter. Set your decimals to 4, and we want to find the maximum value for evaluation. Add another port. This will become our min. Should still be displayed. We're going to set it to 4 decimal places, and we want to display only the minimum value that comes down the pipe. Go ahead and copy those inputs. And connect that up. To get the delta value out of that, we're going to go to our mathematics folder, grab arithmetic. We want operations with 2 channels. Go ahead and connect that, double click it, and we want to take channel minus channel. Say OK. To display that, we're going to go back to our digital display, digital meter, drag him out, double click. This will be our delta. Again, we want to display that on our meter. We'll go with 4 decimal places. And we'll also go ahead and display our RMS value in this meter. So click that, channel name, RMS. Should be displayed. Do 4 digits. And for evaluation, we want to change it to RMS. Say OK. Connect port 0 to 0. Come back to the beginning and drop your wire on for your RMS. Go ahead and bring our displays up. Drag them around and fit them better. This is our delta RMS. I'll drag him down here. Min max. We do have our data logger connected, so if I hit start, we're just seeing what the open port values are. This is pretty much the noise that's in the test system itself. Stop. Alright, let's go get some power supplies and we'll measure our outputs. Okay, we're on the bench now. Here's some of the power supplies we'll be looking at. We have a few more that's not shown. We got some simple PWM supplies. We have an IOTA battery charger power supply. Let's take a look at a old PC power unit. We have a small DC to DC converter. If it would focus. Guess not. We have a BK Precision 1786. We have the Rigol DP832. And for giggles, we'll even throw a battery pack on there and analyze that. I've found it's better to use shielded cable. We'll be connecting to the ground lug with the shielding. We got high-low on the inputs. Let's connect something up and get some numbers. Okay, we have our first test sample set up here. We got our small PWM power supply. Because the input is limited to 10 volts on the data logger, we have to run it through a voltage divider. And the Fluke meter says it is 2.215 volts. Let's see what it says in DASYLab. And here we have our first PWM. Our max is 3.5, min 7.9, delta is 11 volts, and our RMS is 3.2 as compared to our 2.21 on the Fluke. That's interesting. That's kind of a big change there. If anybody knows why, make a comment. I'll dig into it some more myself, possibly. The wave is interesting looking. I expected more of a square wave than a modified sine wave. We'll see what the other ones look like. Okay, we've tested all our power supplies. I've taken that data and dropped it into Excel and created a few charts from it. We'll zoom in a little bit here. I took the data logger and shorted the inputs. This will give us the noise that's in the system, the test system. We were just under 8 millivolts, 0076 to be exact. That is our base noise in the system. That'll be common to all our tests. The BK Precision 1786 is just under 20 millivolts ripple in the output. If you're using sensitive test equipment, that's going to throw your numbers all over the place. The Rigol, these three here, were pretty consistent and very quiet. This is a homemade power supply I built a while back, and it's right in line with the Rigol, so that's very cool. The PC power supply, I was kind of surprised as noisy as it is. We had 12 millivolts of ripple in the output voltages. I'm going to just gloss over these. If you're interested in seeing the waveforms, I'm going to tag them on at the end. And this is DASYLab. Have a great day.